Welcome Algebra 1, Division Properties of Exponents. We're going to work with dividing powers of the same base and raising a quotient to a power. Working with our new Common Core standards of NRR1. As you look at this, the key thing to understand with exponents is that dividing power of the same base. It says you can use repeated multiplication to simplify quotients of powers with the same base. You expand the numerator and the denominator. So if we have 4 to the 5th divided by 4 to the 3rd, that means I have 5 4s divided by 3 of them. 3 of them are going to cancel out as 1 over 1 and simplify, and I'm left with 4 to the 2nd. That leads us into this rule, which this is the rule you should be putting on your dividing powers on your green notes. If we divide powers with the same base, a to the n divided by a to the n, we are going to take the numerator and subtract the denominator when our base, a, is not 0, and m and n are rational. So here are some examples you might want to put down. 2 to the 6th over 2 to the 2nd equals 2 to the 6 minus 2 or 2 to the 4th. What if you have x to the 4th over x to the 7th? Again, x to the 4 minus 7. Taking the numerator minus the denominator gives us x to the negative 3, 1 over x to the 3rd. Now another way you can also think about this one, if you wanted to put down, is we could leave it as 1 over x, and if we take 7 minus 4, we will end up with 1 over x to the 3rd. So if you always keep it where your larger denominator is and subtract, that will also work. What about when you have fractional exponents? So you have s to the 3/4 over s to the half. Again, you're going to subtract numerator minus the denominator, get a common denominator of your two fractions, and gets us s to the 1/4. In problem 1, dividing algebraic expressions, you're going to be asked to simplify. It says, how are properties of divided and multiplied powers similar? For both properties, the base must be the same. Dividing is the same as multiplying by a negative exponent. So if we think of x to the 5/2 minus x to the 2nd, what we're really doing is we're going to subtract 5/2 minus 2. Well, remember, 5/2 is the same as 2.5 minus 2. That would leave us with x to the 1/2. When we do problem B, what we are taking a look at is that we want to make sure n to the 2nd and n to the 5th that we use the same base ones and then our n's. So as we do that, 2 minus 5 and 4 minus 3. We're going to subtract our exponents. As we do that, we have m to the negative 3 and n to the 1. And our solution, no negative exponents, will be m to the n to the 1st over m to the 3rd. I want you to look at the got it problems. Some of the last couple ones get a little more complicated, and we're going to try and look at these. Again, if we are simplifying, we are simply taking our 3/4 minus a half, getting a common denominator, which would be 4, so we really have 2/4. So we're going to have y to the 1/4 power. Here we have 7/2 minus 3, same base, so d to the 7/2, or 3.5 minus 3 gives us d to the 1/2. Still positive exponents. Here again, if we are taking k to the 6th, and in our denominator we have k to the 1st, so we're taking 6 minus 1. Our j, you could keep it in the numerator and take 2 minus 5. Or I'm going to show you another way that you could simplify that if we are looking at this. At this point, we would have had k to the 5th and j to the negative 3, which would equal k to the 5th over j to the 3rd. Now, what if you didn't want to look at the problem that way, and you notice that when you subtract your k's, you have the k to the 6 minus 1, but you notice j is larger in the denominator, so you take 5 minus 2. Would that also work? K to the 5th over j to the 3rd. Please try D and E on your own. Again, with the negative exponents, you're still going to do the same thing. So keep in mind as you subtract those, you're doing the same properties as you did before. I'm going to kind of start D out for you and let you finish it. As we look at that, if we are taking our larger power, A should stay in the denominator. So if we keep A in the denominator because it's larger, we are going to have a to the 5th, and it's minus negative 3. Now this is where you have to be careful. B to the 7 minus 2. Again, the reason I want you to be careful with that denominator is that becomes plus a positive. So we are going to have b to the 5th and a to the 8th. Please try the last one, and we'll check it. You can check it with me in class. Dividing with scientific notation, we're not going to spend a lot of time with this. Look through the example, please. This is not one of our standards right now in Algebra 1, but you should be able to look at when you are dividing scientific notation. What you're really going to do is divide the first two numbers, the 1.21 by 4.81. That gives us the 2.252. Then as we take 10 to the 7th divided by 10 to the 5th, we use our same rule and subtract, so 10 to the 2nd. And now if we write it in standard form, that means moving our decimal over 2 places. Again, take a look at that. We're not going to do many of those problems in our homework. Here's the next notes that you should have, or vocab term that you should have. Raising a quotient to a power. It's on your green notes on the top of that second page. And what it says is we have x to the y, x over y raised to the third. We're going to take each one individually and raise it to that power. So if I have a to the n, a divided by b to the nth power, that's the same as a to the nth over b to the nth, when a and b are not 0, and n is rational, can. So 3/5 to the third, I'm going to take 3 to the third and 5 to the third. 3 to the third is 27 over 125. And the second example, x divided by y to the 5th power is x to the 5th divided by y to the 5th. And here's one more when it's raised to the half power. Now in problem 3, we're asked to raise a quotient to a power. And again, they want you to simplify. We don't want to have a parenthesis and powers. It says, well, how can you check your answer? Substitute the value of the variable in the original expression in the simplified expression, and they should be equal. So if we look at this, we have z to the 2/3 raised to the 3rd power. The first thing, there's couple of different ways we can do this. We're going to multiply this, raise it to the 3rd power, and our 5 to the 3rd. Well, 5 to the 3rd is going to be our 125. And here we're going to multiply now. So we have 2/3 times 3. 2/3 times 3 is just going to leave us with z to the 2nd. So our choice should have been choice D. If you are now looking at the got it problem, the got it question says, what is the simplified form? And again, we can look at taking 4 to the 2nd, and x to the 3rd, when it's raised to the power, is going to be multiplied by 2. So if we're getting that answer, we're going to have 16 over x to the 6th. We're not going to add those, we're going to multiply. Remember the power from the last unit. It says, describe 2 different ways that this could be simplified, and then which one do you prefer? The first way that I want you to try to do it is just simplifying inside the parentheses. So if we go inside our parenthesis first, and the second one is using our raising a quotient to a power. So if we raise it to the power. You're going to see me doing it the first way. I have a to the 3/4, and if I'm going to use my rule, 3/4 minus 5. Well, 3/4 minus 5 comes out to be, and all of that is still raised to the 4th power. 3/4 minus 5 comes out to be a, and if we are looking at that, we should have a negative 4 and 1/4, which if we want to rewrite that, we'd have negative 17/4. So if we had a negative 4 and 1/4 all raised to that 4th power, we really could say we have a to the negative 17/4 raised to the 4th. Well, what's nice is when we multiply, we're going to end up with 1 over a to the 17th, or what is a to the negative 17th. What if we do our powers first? If we do the powers, we're going to take a and take 3/4 times 4. And if we do that, we're left with 3rd power. And then in our denominator, a to the 5th times 4. So here we have a to the 3rd divided by a to the 20th. Since our power is larger in the denominator, remember, we can go with 1 over and subtract 20 minus 3, and it still gives us a to the 17th. Now, what about negative exponents? Remember we talked earlier that negative exponent just really means reciprocal. And here's how you can think of this problem. It's really 1 over ab to the n, but if we take 1 and divide it by a to the n and b to the n, that means taking multiplying by its reciprocal, and that is how we end up with this rule, b to the n over a to the n is the same as b over a to the nth power. So, as we look at problem 4 with negative exponents, you always have a choice of do you want to rewrite it with your positive exponents first, or do you want to raise the powers. Here, what we're going to do first is rewrite it, that part inside the parenthesis as a reciprocal. So y to the fourth over 2x to the third, and it is now, notice the positive exponent. Now we're going to raise our powers. Y to the 4 times 3 gives us y to the 12. In our denominator, we actually have to take, remember, 2 to the third, and then we're going to multiply x to the 6 times 3. That's how we got 8x to the 18. Please try this one, and we'll see you tomorrow in class.